Okay, this is the review sheet for the Chapter 1 test. So let's get started. All right, so this first problem, we are solving an inequality, and that's pretty much just like solving an equation, but with one particular rule that we have to be careful about, and I'll talk about that in just a minute. First, I'm just going to distribute the negative 5 over here on the right side, so that's negative 5 times 2z is negative 10z, and negative 5 times negative 11 is plus 55. So to get z by itself, I'm going to subtract 55 from both sides. That gives me negative 71 is greater than or equal to negative 10z. So here's that rule I alluded to a minute ago. If I divide, and it also applies to multiplication. If you divide or multiply by a negative number with an inequality program, you must switch the inequality. So I'll come up here and put the final answer. 71/10 becomes positive because it's a negative, divide by negative, but instead of greater than or equal to, it becomes less than or equal to. So that would be okay, that would be an acceptable answer, or if you wanted to turn around and put the z first, you could say z is greater than or equal to 71/10. And then you have to graph the solution on a number line, so I'm just going to put 0. Here's 7, and that's going to be just a little bit to the right of 7. It's 7 1/10. So just estimate just a little bit to the right with a solid circle, and we will shade in the greater than direction, which is to the right. So that's the answer for number 1. For number 2, I'm going to get rid of this denominator of 5 by multiplying by 5 on both sides. And that will cancel these, and it just leaves 6 minus 2r on the right side, and it gives me negative 10r on the left. I'm going to add 2r to both sides. So negative 8r is less than 6. I'm going to divide by negative 8 on both sides. And once again, since I'm dividing by a negative, I have to remember to change it from less than to greater than. And negative 6 over 8 is reducible to negative 3 over 4. And then once again, the number line graph of that would be, that's a little bit to the left of 0, just a hair to the right of negative 1. It's going to be an open circle, and then shading greater than, which is to the right. So we'll say that's negative 3/4. Okay. 3, 4, and 5, we have to write an inequality based on words and then solve that inequality. So this is a lot like what we did on the previous test when these were just regular statements, phrases. So let's see what this looks like. The difference of, that means subtraction, 3 times a number and 16. So that's the difference of 3 times a number and 16. Is at least 8. So the way we say is at least is with greater than or equal to. And then once I come up with the inequality, it says to solve. So I'm going to add 16 to both sides, divide by 3 on both sides, and my final answer there for the solution is x is all the numbers greater than or equal to 8. Okay, number 4, 1/2 of a number, so there's 1/2 of a number, is more than, so that's the phrase that we use for greater than, 6 less than the same number. So here is 6 less than the same number. We just subtract 6 from the variable that we have. All right, so I don't have to deal with fractions here at all. I'm just going to multiply both sides by 2, kind of like what we did up here with this problem number 2. I multiplied by 5 to get rid of the denominator, so here I'm going to multiply by 2 to get rid of the denominator, so I don't have to deal with any fractions. I just have to multiply by 2 on both sides. So that makes x is greater than 2x minus 12. And I'm going to subtract 2x from both sides. And I'll finish up here. So 1 minus 2x is negative x. And then these cancel and it just makes negative 12. So multiplying or dividing by negative 1 turns this into x is less than 12. Okay, number 5. 5 less than the product of 6 and a number. All right, so that's what this looks like. Subtracting 5 from 6 times a number is no more than. Okay, so that's another way of saying less than or equal to. Twice that same number. All right, and so now we put our variables on one side. If you wanted to avoid dividing by negative, you could go ahead and subtract 2x. And then you could add 5. And then divide by 4. And then you could stay away from divided by negative, which means you'd have to reverse the inequality. Okay. Let's take a look at number 6. All right, it's a word problem. This guy is translating instruction manuals into Spanish. He's going to receive $15 per page and then $100 per month. Okay, so part of his pay is based on the number of pages he does, and then the $100 is just for working, showing up for work. Okay, he wants to work for 3 months. So here's the key. Write and solve an inequality to find the minimum number of pages he must translate. So that's what my variable should represent. Whatever the answer to the problem is, that's what I'm going to let my variable represent. All right, now I'm going to use my variable in an inequality. So he gets $15 for every page he translates, so that's 15 times x. X is number of pages. He also gets $100 a month, and he's going to work for 3 months, so that's going to be $300. And the way I represent at least is with greater than or equal to, and then 1,500. So there's the inequality. I wrote the inequality. Now I'm going to solve the inequality. So 15x is greater than or equal to 1,200. Just subtract 300 from both sides. And then divide by 15. And 1,200 divided by 15 is 80. So the inequality answer is x, which represents number of pages, is greater than or equal to 80. Let's always answer a word problem with words. He must translate at least 80 pages. All right, takes care of number 6. Number 7, this is a review of our first test. So all of these are going to be y equals mx plus b equations. So for number 7, I'm told that the slope is -2, so I'm going to put -2 in place of m. And then by giving me these other points, I can plug those in for x and y, so that's going to help me find out what b is. So y equals m x and solve for b. So when I add 6 to both sides, I get b is 11. So my final answer is y equals -2x plus 11. Number 8, they aren't quite as nice on this one. Instead of just giving me the slope, I'm going to have to calculate the slope. And this is the formula that I use to do that. So y2, I'll let 7 be y2 minus y1, that's -3, over x2, -3, minus x1. So that's 10 over -5, which is -2. And now you can pick either one of these points. It doesn't matter which. I'm going to use 2, -3. So y equals m x, solve for b. All right, I'm going to add 4 to both sides. So I get b is 1. So the final answer for number 8 is y equals negative 2x plus 1. Okay, and number 9 is two lines that are perpendicular have opposite reciprocal slopes. So this line has a slope of negative 3/5. So that means this line is going to have a slope of positive 5/3. And so now that I know what the slope is, I plug in for x and y, and it's back to what I did before, solve for b. So y equals mx, and then find b. 5/3 times 2, let's come up here, 2 equals, 5/3 times 2 is 10/3. And I can change 2 into 6/3. And then when I subtract 10/3 from both sides, I get 6/3 minus 10/3 is negative 4/3 is b. And now I can write my equation, y equals 5/3 x minus 4/3. Okay, numbers 10 and 11, we have to graph each inequality. Anytime you do an inequality graph, you have to shade the correct side of the line. So number 10 starts at negative 3 on the y-axis, and there's a slope of negative 4, so up 4, left 1. And do that one more time. It is going to be a solid line, so I'll try to draw a straight solid line. And I'm going to do the shading as indicated. Greater than is always above the line. So this is the above side. Below the line would be the beneath or underneath side. So the ordered pairs that would solve this would come from the yellow shaded area. All right, number 11, I got to get this in solve for y form first. So first thing I'm going to do is subtract 2x, and now I'm going to divide by negative 1. So you got to be careful here because that's going to switch the inequality since I divided by negative. All right, start at negative 3. Count a slope of positive 2. Do a solid boundary line through those points. And remember, we're looking at this one, so less than is below the line. So there's the area indicating where the solutions come from. Number 12, another word problem that we've got to do some translating and establishing variables. So we got two things going on here. Drawings are $100 each and paintings are $400 each. Write an inequality that says how many paintings or drawings he must sell to reach the goal of at least $2,000. So I'm just going to let X be the number of drawings sold. Y will be the number of paintings. And now I can use these dollar amounts with these. So $100 times every drawing that he sells, which we're calling X. $400 times every painting that he sells, which we have said is Y. And at least is the inequality greater than or equal to. And that's 2,000. So that's all you have to do on letter A, is write that inequality. Now in letter B, you're going to use that inequality And he says if he sells 3 paintings, well, y is the number of paintings, so just replace y with 3 and then solve for x. All right, so subtract 1,200 from both sides. And answering a word problem with words, he must sell at least 8 drawings. All right, very good. Number 13 is a system of 2 linear equations. So we're going to use the graphing method. I've got to get these ready to graph. So the top equation, solve for y, looks like that. So now I'm ready to graph it. Starts at 5 on the y. It has a slope of -2. And I'll draw a straight line through those. I'll do the same thing for this one, get it solved for y, and that's x plus 2. You just add x to both sides. So this one starts at +2, and it has a slope of +1. So draw a straight line through those. And we want to know, where do they cross? If they cross, that's the solution. And this crosses at the point 1, 3. So that is my answer for excuse me, this problem. X is 1 and y is 3. The substitution method, of the 4 choices that I have, this is the best choice. You always want to go after the variable that just has a 1 in front of it. Solve for that variable. So I'm going to solve for x on the bottom. And then I'm going to replace the x on the top with this. So -2 times 3y plus 3 plus 5y is -2. Distribute the -2. Combine like terms. Add 6 to both sides. Multiply or divide by -1, and you get y is -4. And then you can jump up here and plug -4 in for y, so you can find x. So x is 3 times -4 plus 3, -12 plus 3, x is -9. So as an ordered pair, our answer will be -9, -4. Elimination, we're trying to make either x or y cancel. So you could, it really doesn't matter. I'm going to choose to eliminate y. So that means I'm going to have to multiply the top equation by 3 to make this become -6y. And then I'll multiply the bottom by 2 to make this become +6y. So they will wash each other out when we add these together. So 15x minus 6y is equal to -57. 4x plus 6y is equal to 0. So make sure you multiply by all the terms in the equation, everything. So if I add these two together, 19x is equal to -57. So x is -3. And so just pick one of the equations to go back into. So I'll go to the bottom. Just use this equation. 2 times -3 plus 3y is equal to 0. Add 6 to both sides. Divide by 3. And my final answer as an ordered pair is x is -3, y is 2. All right, 16 is a system of 2 linear equations, but we have to come up with the system and then solve it. So again, these are two different plumbing companies, and they each have a different way of charging for their service. One has a less expensive house call but more per hour rate. The other has a more expensive house call but a little less per hour rate. And we're trying to compare just to try to see which one might be the best to use. We have to come up with a linear equation to represent how they charge. So since the question I'm supposed to answer is how many hours must be spent on the job, X is the number of hours spent on the job. And since this is a linear equation, that means y equals mx plus b. If x is the number of hours spent on the job, y is going to be how much they end up charging altogether. So, dollar amount charge for their work. Okay, so let's do fix it fast. $25 for a house call, and then it's going to be $50 for each hour. So their charge, Y, is going to be $50 times the number of hours they work, and then they're going to charge you $25 just to show up and estimate what it's going to cost. Take a look at your job. Do it right. They're a little different. It's $45 per hour, and then it's $35 to show up and tell you what to do or what needs to be done. And so now we get to solve this. Well, it's just a system. It's just like these. And you could use any method you want. I think substitution makes sense because if y is already solved for, then you can replace the y up here and solve for x. So this is just substitution. All right, and then I'm going to subtract 45x from both sides, subtract 25 from both sides, and my answer for how many hours must be spent for the two plumbing companies to be equal, it would be for a 2-hour job. It's x is 2. We charge the same amount if all you have is a 2-hour job. Okay, let's do some systems of inequalities. So it's graphing two boundary lines and do the shading and see if the shading meshes, comes together, see if it meets. So here's the top one. It starts at -6 on the y with a slope of 3. Solid line. And it's less than, so when I do the shading, I'll just put an arrow. I'm going to be shading this way. Less than is below the line. All right, this one starts at 2 on the y, and it has a slope of -4, so up 4, left 1. It's going to be a dotted line. And it's greater than, which means above the line. So I'll be shading over on this side. What I care about is where red and black come together. And you can kind of see that they come together right here. Black below, red above. So the overall answer is going to be the yellow area on this right side, above the red dotted, but also below the black solid. Okay, number 18 is a V with a line, so just want to refresh your memory a little bit on how to find the vertex of the V. So the opposite of M is 2. B is 1, C is 0. So using my formula, I get a vertex of negative 1/2, 0, which is right there. And then from there, I count a positive 2 and a negative 2 slope. I do a dotted V. And when I do the shading, I'm going to do greater than, which will be above both lines, so it'll be inside the V. Now let's do the line y equals 5. Well, that's just a horizontal line. It's going to be dotted as well. It crosses 5 on the y-axis. And it says less than, so I'll be shading below. So inside the V, but below the red dotted line, that's an area that I'm going to indicate with the yellow again. It's right in here. All right, so here we have a 3-variable system. And right off the bat, I would take a look and see if there is a particular variable that looks easier to eliminate. And I'm going to go with Z. I'm going to eliminate Z. So I need 2 pairs of equations. I'm going to do the first and the last paired together. And I'm going to eliminate Z there in just a minute. And then I'm going to do the second and the last. And just remember, you got to eliminate the same variable on each side with each of these. So I'm going to do Z here. And to eliminate Z, I'm going to multiply by -5 on the bottom. So 25x minus 15y plus 5z is 85. All right, so we don't really need to look at this one now. So let's add these together so that we can eliminate z. So 2 plus 25 is, let's work this out, 27x. 4 plus -15 is -11y. The z's are gone. And 85 plus 18 is 103. Okay, so I've got to eliminate z over here as well, so I'm going to multiply by 2 on the bottom. And let's see what that gives me. -10x plus 6y minus 2z, and that's going to equal -34. So we'll not look at that one anymore. So let's add these together. -3 plus 10 is -13x. 5 plus 6 is plus 11y. The z's cancel. And -27 plus -34 is -61. Okay, so now these two equations that remain, you put those together and do elimination again. And it works out really well because the y's are going to eliminate automatically just by adding these two equations together. So 27 minus 13 is 14x. And the y's cancel, of course. So 103 minus 61 is 42. So x is 3. All right, now you can go back into either one of these, doesn't matter which, and replace x with 3. and you can find y. So I'll just come over here, 27 times 3. That's 81. And 103 minus 81 is 22. So y is going to be negative 2. And now once you found two variables, you can come back to any one of these original three, doesn't matter which. I'll just go to the top one. We can replace x with 3. We can replace y with negative 2. And we'll solve for z. Add 2 to both sides, divide by negative 5, and so z is negative 4. So as an ordered triple, 3, negative 2, negative 4 is my answer for number 19. Number 20 is a word problem that it contains 3 equations, 3 variables. So I need 3 variables because this is wanting us to find 3 numbers. So x is going to be the first number, y will be the second, z will be the third. All right, and it works out really well. There's 3 sentences that represent 3 equations. So here's equation number 1. The sum of 3 numbers is 6. Right? Here's equation number 2. The third number, which is z, means equals the sum of the first and the second numbers. And then here's equation number 3. The first number, which is x, is 1 more than the third number. So that's saying the third number plus 1. And so since I've got z solved for, and there are 2 other z's that I could replace, I think it makes it easy just to replace these other 2 z's with x plus y. This is just the substitution method. So the top equation will look like this when I replace z. (2x plus 2y equals 6). All right, and so I'll replace z up here. Now I'm going to replace z down here. X equals x plus y plus 1. When I subtract x from both sides, I get 0 equals, this is going to be 0. So the x's just cancel out. And then I subtract 1 from both sides, and that gets me the second number. The second number is going to be negative 1. And then I can use that over here to find the first number. So the first number is going to be 4. And then you can go to the middle now that you know x and y, and you can use this middle equation to find z. X is 4, y is negative 1, so z is going to be 3. So there's your answer for that word problem number 20. And then we have a little bit of review on radicals. So on these radical expressions, first multiply the numbers that are not a part of the radical, 4 and 3, and then go ahead and multiply the 2 radicals. So 3 times 8 is 24. X to the third times x to the fifth is x to the 8th. Add the exponents. Y to the 5th times y to the 2nd is y to the 7th. Okay, now let's remember how do we simplify, starting with the square root of 24. So I'm going to use the square root of 4 because it's perfect with the square root of 6 because it's not. The square root of 8, 8's already divisible by 2, so I'm putting x to the 8th. It's already perfect. But y to the 7th is not, so I'm going to make y to the 6th over here because it is perfect. But I'm going to put y over on the right radical to make it equal. So this first radical simplified becomes the square root of 4 is 2. The square root of x to the 8th, it's like x to the 8 divided by 2 power. And y is to the 6 divided by 2 power. So all of this is just being multiplied together. Well, these you can literally multiply together. 12 times 2 is 24. And you just have to show that that's being multiplied by the radical. And there's your answer for number 21. 22, this is a cube root, so I got to remember the perfect cube root numbers. 8 is one of those. 8 has a perfect cube root, and times 5 makes 40. 8 to the 8th isn't a perfect cube because 3 doesn't divide into 8 evenly. So I'm going to try to simplify that with 8 to the 6th. 3 does go into 6, but that makes 8 to the 2nd over here. B to the 3rd is already good. 3 goes into 3. C to the 5th can't be fully simplified, so I'll do C to the 3rd with C to the 2nd. So the cube root of 8 is 2. A to the 6 divided by 3 power. B to the 3 divided by 3 power. C to the 3 divided by 3 power. And then this other radical is unable to be simplified. Okay, we're almost done. We got some exponent work to do. This first expression, everything gets raised to the second. So 4 to the second, x to the 5th raised to the second. That's just when you multiply exponents together. X to the 5 times 2 power. Y is going to be to the 3 times 2 power. And now over here, 2 to the 3rd is 8. X to the 3 times 3 power. Y to the 2 times 3 power. And now you multiply the coefficients together. 16 times 8. 128. And now that I'm multiplying, I add the exponents for variables. So x to the 10 plus 9 power. Y to the 6 plus 6 power. All right. In here, everything that's being multiplied gets raised to the negative 2. So 5 to the negative 2 times x to the 3rd raised to the negative 2 makes x to the negative 6. And then y to the negative 4 times negative 2 makes positive 8. So only one of these is good as it is. The y to the 8th doesn't need to be changed at all. Don't change y to the 8th, but these other two with negative exponents have to be changed. So I'm leaving y to the 8th on the top of the fraction, but I'm moving 5 squared down to the bottom, and 5 squared is 25. And x to the negative 6, when it comes down to the bottom, becomes x to the positive 6. And that's the answer for 24. And then our last one, this negative exponent, since this is a fraction, I'm just going to flip it over. And then once I do that, I can change it to a positive exponent. So once again, everything gets raised to the 3rd, 4 to the 3rd, x to the 4 times 3 power, 3 to the 3rd, x to the negative 2 times 3 power. And I'm going to move x to the negative 6 from the bottom to the top. And when I do that, it becomes, it's no longer x to the negative 6 on the bottom, it becomes x to the positive 6 on the top. And now you can put these two together to get your final answer, 64x to the 18th over 27. Okay, I think we did it. So I hope that helps you get ready for your test. If there's anything else I can do, please let me know. Prepare well, and I'll see you next time.